basically, definition shows a distant retrograde orbit, was to ensure that we didn't leave a cloud of debris, as someone mentioned, but also it's a very stable orbit that could allow the rock to be in a position where it won't harm anything for quite a long time, as some calculations showed as long as 100 years. So I think it's interesting that people are thinking about, what ways can we use the station, and I think there's other studies that are being pursued to explore that, but for the reference concept here, we didn't explore that option. Very good. Another question or comment from the floor? Anybody? Anything at all? Yes, sir?
So I have to write the final report for this workshop, and what I'd really like to see are some recommendations from this group, not just findings.
That's fine.
On future steps and studies. And I had a couple of comments. It seems like there's some potential strengths of the expandable or deployable boom concepts relative to inflatables. So, they might have less weight because you don't have an inflation system. They might have better spin dynamics. We really need to investigate that. So one potential recommendation would be to do some comparative studies of deployable boom concepts versus the inflatable concepts. And the other thought was that the yo-yo D-spin could be used with the mothership, like the reference concept that Brian showed at the beginning. We've already captured the asteroid, and the spacecraft goes through these wild tumbling maneuvers, and so maybe we just deploy a CubeSat off the back of the mothership, and that would reduce some of the burden on the RCS. I don't know if it trades from a mass standpoint. Are you saving propellant versus a CubeSat? But we should look into that. So
we looked at yo-yos for de-spinning because we are planning to use up to about 200 kilos of RCS propellant to do this job, and so that's not a trivial amount. The concern we had was that the yo-yo could get tangled in the solar panels and things like that, solar array booms. And so if you consider all the possible spin states, it's not obvious that there's any place you can put a yo-yo that doesn't risk entanglement. And so that was why we decided, because there definitely is a mass advantage. You could get down to 5 or 6 kilos of yo-yo to do this job with kilometers of tether. But we could not see a way that in all the pathological spin states that you wouldn't risk entangling the spacecraft. Well, our driver. The question that Bo asked is what about leaving and pulling back and just leaving the yo-yo? And the concern we had is the separable spacecraft cost. And so because our charter was to minimize the cost of this mission, we elected not to study in any detail any of the concepts that had a separable spacecraft. Certainly you can imagine a separable spacecraft that doesn't have solar array booms, or certainly not large ones, that goes up and does something. But most people, when they hear a second spacecraft, the cash register rings, some large number of millions of dollars, and whether that's true or not, that's the environment we live in, and that's what reviewers are going to think. And so we did not put any effort into studying that.
So just two more thoughts. One, should we look at retractable solar arrays so we don't have to worry so much about breaking them? We do have some concepts for large solar arrays that can be retracted and extended. So we need to trade off the risk of that versus, the lower loads on a retracted array. And then finally, I thought Brian Muirhead raised a good point, and we really need to look at this other mission scenario where we pluck a boulder off the surface, and most of our capture system concepts are for capturing the whole asteroid, but we don't really have a lot of good ideas yet on how to pluck a rock off the surface other than the one that Brian showed. So, but yeah, please come up with some recommendations. Those are just some
Sure.
ideas.
No, I think those are good inputs, because one of the challenges I think the agency sees is we've done a certain amount of analysis on our own, but we'd also, this whole workshop has been intended to solicit ideas and concepts from industry and academia and the general public. So every idea that you're bringing forward, I'm writing it down and going to try and synthesize it together. And I've worked with Chris closely before on a number of ideas and concepts. So we're trying to capture everything that we can to bring more informed analysis and decision making by the agency. So we appreciate everything y'all are bringing forward. Next comment.
I'd like to speak to a number of the comments that were just made. One about retracting solar arrays. Already in industry, one of the things we sometimes do if there's a Leonid swarm or meteorites approaching, we feather the arrays to present a minimum surface area towards the radiant of the meteor stream. So there is a little bit of heritage in that direction already. But the next thing one might think about is to have a sort of hinge mount underneath where the SATA is, and just hinge the solar array out of the way. And then the SATA might not be able to be operable, and it would rotate to a desired position and then be hinged out of the way, and you wouldn't operate the SATA anymore until you hinged it back. That would be one way to approach that. One other thing is I perceive a desire not to cause any structural deformation or physical change to the asteroid that we're trying to capture, but it's a sort of a mirror image of the notion of pick up a rock. What you might say is, we've got this irregular object we're trying to capture here, and it's got undesirable spin on it. Maybe what we need to do is to give it a shave. As somebody who wears a beard, I can see this point. Give it a shave before you bring it home. It needs a little cleanup. And we'd like to bring it home pristine, but the way we found it. But we'll take good pictures of it, and then we're gonna cut this irregular piece off, maybe with a robot arm hitting it. And maybe by doing that, we also change its mass properties. That's one of the things in commercial spacecraft we concern ourselves with a lot, the mass properties of the object. If you gave it a shave, it would then be all set up maybe for a more benign D-spin.
All right, thank you. Marshall?
So in following up on what he said, I think one thing that this group might sort of convey back upstream is that the object will in fact be changed. How it will be changed is unclear. You can say, well, we'll try not to modify it or whatever, but we don't really know. We might touch it and it falls into pieces. You don't know. And so a question to relay upstream is there anything that we really need to measure before we touch it? He just mentioned taking pictures. Well, is that one of the goals? Do you have to take pictures from all sides? And so on. I mean, I think really the thing that this group could do is just sort of raise that flag and just say, hey, things are going to be changed, and don't come to us afterwards and say, oh, but now we can't,
Right.
now we can't determine this because you mucked with the surface.
So one of the things we've done in some of the studies over the spring and summer is try to engage the planetary science community to understand what characteristics they want to be able to explore and understand. So your input is right in line with some of the things they've been talking about.
Yeah, I mean, and not even in a sort of bigger picture, you might even consider going to the Lunar Planetary Science Conference that's coming up or whatever, and giving a presentation on that and saying, what should we be thinking about? What's important here?
Very good. Thank you. Next commenter.
Yeah, so my comment is to Chris's point about this alternative mission concept to grab a boulder off the surface, and it relates to the concept that Brian Muirhead presented as well. I think it would be at a high level useful to think about these concepts that were presented today for that alternate approach, but I would put out a strong word of caution that the constraints are very different. If you're capturing an object that's in free space, you have a lot of flexibility, whereas if you're capturing an object that's fixtured to something else, you're going to want a different kind of system. Specifically, you can't have isotropic compliance because that boulder is going to be potentially much more massive than your spacecraft. So if you're slightly misaligned, or if the boulder is bulging on one side, you're going to make contact with that first. That's going to impart loads to your spacecraft that are going to cause you to tip over. So, the work Dan is doing is going to tell us how well that boulder may be fixtured to the surface. But if you look at, the field of robotic manipulation, they'll tell you it's a very different problem to pick up a ball on a table than it is to grab a ball-shaped doorknob that's fixtured to something. So you need to consider that when we look at extending the concepts.
Okay, very good. Thank you. Next comment, do we have anything more from the online? You've asked a lot of questions today. You look like you're primed to ask a question or can make a comment.
It was, as far as the tethers go, would it be possible to use the spacecraft itself as the yo-yo and, pull it away and keep it tethered, and then not only would you not have to worry about anything getting entangled in solar arrays or things, but you'd also increase your lever arm, which I would think would allow you to use less propellant in trying to de-spin.
And Brian, do you have anything to say about that?
We did not explicitly consider that, but certainly that could be done, and you probably would reduce your propellant significantly by doing that. But once we were down in the 200 kilo, considering that we're carrying 10 tons of xenon, we felt that, that just the added complexity would not be a good. It's a lesser version of the separable spacecraft argument. Basically, that means that the whole system that captures the whole capture mechanism has to be releasable, which we already have, because if we decide, later when the astronauts are deploying it, if we decide we want to use the SEP system for something else, we already have SEP nuts and so on that can pop off the whole capture system. But then you have a requirement that you be able to reel it back in on the tether and reconnect, redock with it. And so that's a whole new set of requirements and hardware that we felt was just going to add. The 200 kilos of RCS propellant seemed like, it was small enough to not be worth considering the need to redock with the capture mechanism.
All right, Mr. Enriquez?
Yeah, I just wanted to bring up the point we really didn't discuss in detail.
If you could move a little closer to the mic.
Sure. We didn't discuss in detail the transition between what we consider the soft capture phase, or when we're trying to attach ourselves to the asteroid, and what we call the final hard capture phase. I believe that that's one of the areas that we needs to be looked into more in detail, since we know that transition is going to give rise to loads that can be imported either to the capture system or to the spacecraft. And so that area, which always gave us, in our design of attachment systems for the space station, was the challenge. And so we still have the challenge here, particularly now that the asteroid is rotating. So I wanted to bring that up as an area that really needs to be looked into more closely.
Thank you. Appreciate that. Any other thoughts or questions? We got plenty of time, but I know that some people may want to go to lunch, so we don't want to unduly restrain you. Wanted to say again that we've the agency again has been seeking outside input. This is one mechanism, but there are other ways that the agency explores. There are different advisory bodies and then consultations with partners all around. So don't feel like this is the only opportunity to provide some inputs to NASA. And I think through the website and some of the other mechanisms, we've definitely got opportunities there, and then the agency is going to continue to do its formulation work and explore not just this area of capture systems, but all of the dimensions of the mission as was stated and defined in the RFI. And then, of course, Brian Muirhead's talked about the alternate mission concept, which we didn't solicit inputs via the RFI. So there's other activities that may guide and influence the work that we're doing here today. Anything more from the online, Pedro?
Yes, I found a few questions now on Twitter. And there's a question for, let's see, Harold on can the asteroid regolith be used to augment the end mass for very large asteroids, basically gather mass like a starfish? A similar question for Jeff, could CubeSat eat some regolith and store it in a small ballast bag prior to deploying the tether, basically augmenting your end mass?
Okay, Howard, if you could go first.
Oh, I just had a comment that there's a huge need for an EP tug in the Earth-Moon system beyond NASA, and so it's very possible to get other mission partners who could contribute funding for that capability. There is an issue of mission control, so it has to be, carefully crafted so that this mission isn't impacted, but this would have a lot of utility to those other areas.
Okay, so the question that, someone online had a question for you.
Oh, for me?
That's
I'm
yes.
sorry. I
So
was
say-
thinking about my question.
That's fine. Say the part about, for Howard again,
Sorry about that.
real quick, Pedro.
Sure. Okay, so it says, would tether capture, hold on. Can asteroid regolith be used to augment the end mass for very large asteroids?
So, let's see, others at JPL might want to comment on that. They're the ISRU kind of gurus, but that would be a whole development beyond this. So eventually, that's a goal, I believe, of this mission, is to understand the asteroids enough that that could be done. To put that level of risk into this mission would be, would probably put too much on this one mission.
Okay, and then we had a question, I think, for Jeff, the part on the tether.
And basically, I'm guessing these two questions are related. It says, could CubeSat eat some regolith and store it in a small ballast bag prior to deploying the tether?
Technically, it could. The D-spin, I think, is the square of the tether length, and the tether weighs nothing. It's basically dental floss. So from a complexity standpoint, I don't think it would be worth it, because you could just add another couple kilometers of tether if you wanted to at almost no penalty.
Okay. It looks like we've got do you have a comment? If you got a comment, could you come to the microphone?
Yeah, I think the fellow before answered it pretty well. I mean, for the tethers, when we were looking at having a spacecraft, capture, the asteroid, that would be mass that you could. I mean, it's already connected, So the added complexity, like the other fellow mentioned, is a lot more difficult.
Okay, thanks. So if I can maybe do a little recap, just to kind of play back some of the general conversation we've had in this commenting session. We've got feedback from on trying to understand, how much impact does the capture have on the asteroid? What provisions should we look at exploring to address that? We know that there was a variety of different objects out there for consideration. Some of the early analysis has been on NEOs that are not binaries, but there's a whole nother session that I think took place on the first day of the workshop back in September that looked at asteroid observation. And so I think one of the key elements of this entire initiative is to try and understand and characterize the asteroid targets that are being considered. So I'm hoping that that would yield the information that we would need to address the question about the potential for a binary that we didn't realize. I think there's been a lot of discussion overall about how do you work with a rubble pile or a dirt clod asteroid. So any capture system that's being envisioned is going to have enough flexibility or robustness to handle, a range of potential materials. Understanding the composition of the asteroid, again, I think is going to be a big part of the observation campaign. Chris Moore brought forward the idea that we do need to explore some of these areas in greater depth, and I think we've certainly got a great starting point for pursuing that. So I'm happy to add that into the presentation, Chris, that we'll be making tomorrow, to at least propose that as a forward plan. I think those are the main things. Obviously, we talked some more about the yo-yo effect and the tethers. Scott, you had a comment?
About tethers and the changing mass properties that we would expect in a rubble pile. So say we cast the net or the bag around it and then start to do the tether despin. I would presume that the forces in the bag are going to start changing the shape of that rubble pile. How can the tether system accommodate for that?
Okay.
Goes out to the tether guys.
Okay. Yes, so Brian, you have a comment?
I'd just like to emphasize for the group that the forces in all of this are very small. A few newtons, a 1 pound of force is enough to do everything you need to do on this mission. You don't need significant forces in the terms that most aerospace engineers you think of large forces. So we hear people talk about, it needs to be strong and so on. It doesn't really need to be very strong. When you work out the forces, most of you probably already done a lot of the back of the envelope sophomore physics on this, and if you just, with just a little bits of force, you can despin these things over hours, which is good enough to solve the problem. So more key is the point that I tried to make and that Dan Shears made, that this material could be way under 1 psi compressive and shear strength, and as a result, that's why we ended up with these capture bags that are inflated to much less than 1 psi, something comparable to or less than the shear and compressive strength of the regolith material. Now, once you compress it, of course, you add strength. So when you confine the thing from all sides, it'll tend to be more cohesive than it would just in free space. But as long as we as we inflate the bags, we watch the IMU of the spacecraft, and if the IMU says the spacecraft is not doing what we thought it would do, for example, if the center of mass is slightly off from where we thought the center of mass was, we adjust the inflation pressures so that we don't, number one, we don't want to trigger adverse, excessive forces on the spacecraft solar arrays. But number two, we don't, we want to take that into account in the future dynamic, prediction of where we're going to be, where we're going to fire our RCS thrusters to start detumbling and despinning, things like that. But we have 22 Newton thrusters, which actually turn out to be, large, for what we really need to apply in terms of the despin forces. So we're going to try not to modify the shape of the asteroid, and the yo-yo would be probably have even less force than the 22 Newton RCS thrusters. So once you start to deploy the yo-yo, if you did it that way, you would do it slowly, so that again over a period of hours or days, a day or a couple of days, you could despin the thing easily and with just 1 pound of force.
Thanks, Brian. Really appreciate that. All right. Well, I think we've done a great job here this morning of trying to canvass all of y'all. I think there's a lot of areas in which I think different folks have brought their expertise and their perspectives. Certainly, the industry partners have been very good in sharing what their flight experience has been and how they've applied their technologies to other domains. We've had some representatives from academic community sharing what their experience, and then NASA personnel from the study teams also shared their experience. So I think we've got a good broad cross-section of folks taking a look at this problem. We really appreciate all of the responses to the RFI, and particularly y'all who are able to join us here today. What I would invite you to do is to participate in some of the sessions this afternoon. There's a crewed system session. I think, is it going to be in this room, Pedro? Okay, so look at your program to figure out, I think we've got 3 sessions this afternoon, 2 to 3 sessions, some here and maybe one in the lecture hall. And then tomorrow, between 10 and noon. They're slated to have a summary or outbrief of each of the sessions, so I'll be doing the outbrief from this session. And if you want to get some additional thoughts to me between now and then, I'm andre.j.sylvester@nasa.gov. If you want to send me a quick email note, I'd be happy to at least respond to you. But again, I'd like to thank everyone for their participation. Enjoy maybe a little bit longer lunch break. I think the whole activity starts up again at 1:30 this afternoon, and because of the bus system we've got, I would say give yourself some extra time in getting back here. Allow for the transit time of the bus. Very good. Well, thank you all for coming, and thanks for participating.